Hello and welcome back to Math with Mrs. Becker. Today we are looking at proportional reasoning in Algebra 2. The chapter is Chapter 2 and we are looking at Section 2. Recall that a ratio, what that means is that we are comparing two numbers through division. So a ratio means that we have a fraction, okay? A proportion is an equation. Remember, an equation means that you have to have an equal sign. A proportion is an equation stating that two ratios are equal. So a proportion is two fractions with an equal sign between them. In a proportion, the cross products are equal. What that means is that if you are trying to see if a statement is really a proportion, or if you are trying to solve for a variable that is placed in a proportion, the process that you use is cross multiplication. Let's go ahead and flip this over. Okay, here's an example of a proportion. This states that the fraction 3/5 is equal to the fraction 9/15. The way that I can test and make sure that it is a proportion is you do cross multiplication. I take the top value of the first fraction times the bottom value of the second fraction. 3 times 15, that equals 45. Now it's equals, you go the bottom of the first fraction times the top of the second. 5 times 9 is 45. If these two values are equal, that means yes, that is a true proportion. If a proportion contains a variable, you can use cross products to go ahead and create an equation that we can solve. Let's go ahead and try some. If I want to solve for p, I take the top of the first fraction times the bottom of the second fraction. If I go ahead and I do that, it's 16 times 12.9. 16 times 12.9 is 206.4 equals. Now it's the bottom of the first times the top of the second. If I take p times 24, I get 24p. Now, if I want to solve for p, that means get p all by itself, I need to get rid of the 24. Right now, it's 24 times p, so you do the opposite operation, which means I divide. P is all by itself. If I take 206.4 divided by 24, I get 8.6. So what that means is the value of 16 over 8.6, that is the same value as 24 over 12.9. That process is called cross multiplication. Let's go ahead and try another one. Top of the first times the bottom of the second. 14 times 132. 1,848 equals bottom of the first times the top of the second. 88 times c is 88c. I want to get c by itself. So whatever's next to c, in this case, we're multiplying by 88. That's what I have to eliminate. To undo multiplication, I divide. C is all by itself. 1848, if I go ahead and I divide by 88, C equals 21. Okay, let's look at another one. Top of the first times the bottom of the second. Y times 84 is 84y. Bottom of the first times the top of the second. 12 times 77 is 924. To solve for y, I need to divide both sides by 84. That way y is all by itself. 924 divided by 84 is 11. Last one on this slide. Top of the first times the bottom of the second. 15 times 7 is 105. Bottom of the first times the top of the second. 2.5 times x is 2.5x. If I want x by itself, I need to get rid of the 2.5. Right now, the 2.5 is being multiplied, so the opposite operation, I need to divide. 105 divided by 2.5 is 42. So that process is called cross multiplication. Anytime you have an application problem that deals with percentages, you can create a proportion and use cross products in order to solve. When you have percent, What that means is that it's out of 100. So 30% is 30 over 100. 11% is 11 out of 100. 90% is 90 out of 100. Okay, so we are going to go ahead and solve real-life scenarios by creating a proportion. There are two methods that you can do this. I kind of went ahead a little bit. Today we're going to do proportions. Then in chapter 3, we create what's called a percent equation. So I got a little excited and tried to get us to jump ahead. Today we will just do method 1, trying to create a proportion. Okay, well, let's do this. A poll taken one day before an election showed that 22.5% of voters planned to vote for a certain candidate. If 1,800 total voters participated in the poll, how many indicated that they planned to vote for that candidate? Step 1, find your percentage, and you turn it into a fraction. 22.5% means 22.5 over 100. Now, the other value we have is 1,800. We have to figure out, does 1,800 represent the 22.5%, or does it represent the total amount of people who voted? This says 1,800 total voters. So the total is 1,800. So that goes with the 100%. What we want to do is find out how many indicated that they plan to vote for the candidate. Well, 22.5%. So we want to know what 22.5% of that 1,800 is. So we cross multiply. If I go ahead and take 22.5 times 1,800, I have 40,500 equals 100 times x is 100x. To solve for x, I need to divide both sides by 100. I can cross off a 0 and I can cross off a 0. 405 divided by 1 is 405. So what this tells us, there were 1,800 people who went and voted. 22.5% or 405 of the voters voted for that particular candidate. 405 is 22.5%. Awesome. Let's do one more just to make sure that we've got it, okay? At Clay High School, and again, we're only doing proportions. At Clay High School, 434 students, or 35% of the students, play a sport. How many students does Clay High School have? Step 1, find your percentage, turn it into a fraction. 35% means 35 over 100. Now, the other number that we have is 434. Does 434 students, does that represent the 35% that play sports, or does that represent the 100% of students that they have there? This says 434 students or 35%. So that means my 434 goes with the 35. The question says, how many students does Clay High School have? So we are looking for how many total. Total has to go with the 100%. Cross multiply. 35 times x is 35x. 100 times 434 is 43,400. If I want to solve for x, I need to divide both sides by 35. If I take 43,400 and I divide by 35, I have 1,240 students. That's how many total students there would be at Clay High School. So the previous two examples are just showing you you can take any percentage and turn it into a fraction by removing the percentage symbol and giving it a denominator of 100. All right, let's keep looking. A rate. A rate is a ratio, meaning we have a fraction, and it involves two different units. So things like miles per hour, okay? Miles per, remember per means division, miles per hour, okay? So two different labels. This is words per minute, how fast can you type? Dollars per gallon of gasoline. Rates can be helpful if you're trying to solve some real life situations. The difference between a rate and a ratio. A rate has to contain two different labels. The top and the bottom are going to have different labels. All right, Ryan ran 600 meters and he counted 482 strides. So as Ryan was running, he was counting 1, 2, 3 every time his foot hit the ground. How many strides? It took him 482 strides to go 600 meters. How long is Ryan's stride in inches? Holy smokes. Use a proportion to find Ryan's stride in meters first, okay? Then we have to convert meters to inches. So here's the deal. Ryan went 600 meters and it took him 482 strides. So that goes together, okay? And I can even just go meters. 600 meters, that's how much Ryan could travel with 482 strides. Those two values go together. Well, we want to know how many meters is one stride. Now realize I lined up the labels. Meters are on the top, strides are on the bottom. The question said is, how long is Ryan's stride? That's singular. You want to know 1. So I go ahead and I cross multiply. 1 times 600 is 600 equals 482 times what we're trying to find. So that's 482x. If I want to know how many meters one stride is, I have to go ahead and divide. 600 divided by 482, it's approximately 1.2448. Okay, this is what I got on my calculator. 1.2448, so I'm going to take this 8 and bump that up to a 5 and go 1.245. 1.245. That's what x equals. So what that means is one of Ryan's strides is 1.245. That goes on the top. On the top, the label is meters. Okay, so this is meters. Now the question says, how long is Ryan's stride in inches? Okay, well, this tells us that 1 meter goes with 39.37 inches. We know that Ryan's stride is 1.245 meters. Meters is on the top. We want to know what that is in inches. Cross multiply. 1 times x is 1x. I go ahead, take 39.37 times 1.245, and I get 49.01, so I'm just going to say approximately 49 inches. The main thing here is you have to make sure that you line up your labels. Like here, meters are both on the top, strides are both on the bottom. Here, meters are both on the top, inches are both on the bottom. Wherever your variable is. Here, variable went with inches, so that is my label. Okay, let's do another one. A 5K walk is a distance of 5 kilometers. 1 kilometer is about 0.62 miles. So those two values go together. So I can take those and turn them into a fraction. 1 kilometer is 0.62 miles. How far is a 5K walk in miles? Well, kilometers is on the top. So if I'm looking at a 5K, I want to know how many miles that is. Cross multiply. 1 times x is x. If I take 5 times 0.62, it is 3.1. The variable is on the bottom. The label for the bottom is miles. So if you say, hey, I'm going to join you and do a 5K, what you are signing up for is to run 3.1 miles. Now this is where it gets kind of fun, at least for me. Similar figures, okay, from geometry. Similar figures have the same shape, but not necessarily the same size. Two figures are similar if their corresponding angles are congruent. That means that their angle measurements, that are the angles that are in the exact same spot in the shape. Their angle measurements are congruent, which means that they are the same. Okay, their corresponding sides. So their sides that are in the same location are proportional. Proportional means that we can find missing values by creating a proportion. So let's go ahead and do this. Now, this is where it gets fun. Be silly, draw fun pictures. A tree in front of Luke's house. So there's a tree. There's Luke's house. Beautiful house. There we go. We'll give it a door. And we'll have some round windows because that's kind of fun. Okay, there's Luke's house. It looks like a happy house. The tree in front of Luke's house casts a 6-foot shadow. So there's the shadow. This is 6 feet. At the same time of a day, his house casts a 22-foot shadow. If the tree is 9 feet tall, how tall is the house? I can turn these both into right triangles. I know that the height of the tree is 9. This is what I'm trying to find, okay? So the height of the house lines up with the height of the tree. The shadow of the house lines up with the shadow of the tree. So this fraction, the measurements all came from the house, x over 22. Here, 9 over 6, both of these values came from the tree. Notice that they're in the same spot. The top of the fraction is the height. How tall is the object? The bottom is the shadow. But each fraction is from the same object. This is from the house. This is from the tree. Cross multiply. X times 6 is 6x. 22 times 9 is 198. If I want to solve for x, I just need to divide by 6. 198 divided by 6 is 33. The label is feet. So that house is 33 feet tall. Turn page. Jake is 6 feet tall. All right, let's draw Jake. Jake's got some curly hair, and Jake's doing math, so Jake is happy. And Jake is 6 feet tall, so he's about a foot taller than me. He casts a shadow that is 15 feet tall. So look at that, we got a right triangle. At the same time, a tree casts a shadow. So we have a tree. This tree casts a shadow that is 50 feet long. How tall is the tree? So the height, 6 feet goes with, we don't know, feet. It's the height of Jake and the height of the tree. The heights are on the top. The shadow for Jake is 15 feet. The shadow for the tree is 50 feet. Cross multiply. 6 times 50, you get 300. So it's 300 equals 15 times x is 15x. Go ahead and divide both sides by 15. 300 divided by 15 is 20. So that tree is 20 feet tall. One more. A 6-foot tall climber casts a 20-foot long shadow. Okay, so this guy's climbing. I'm not sure what he's climbing, but hey, he's 6 feet tall. His shadow is 20 feet. There's my triangle. And he's climbing, so we better give him a hat. We want to make sure he's being safe. And maybe a backpack. See how much fun this can be? And a bottle of water because we don't want him to get dehydrated. And of course, he's happy. Okay, there we go. So there's a climber. A 6-foot tall climber casts a 20-foot long shadow. At the same time, a tree casts a 90-foot shadow. How tall is the tree? 6 feet goes with, we don't know, feet. Over 20-foot shadow goes with 90-foot shadow. How tall is this tree? 6 times 90 is 540. 20 times x is 20x. Divide both sides by 20. 540 divided by 20. That tree is 27 feet. And that, my friends, is 2.2. Your assignment for today is worksheets. Hope you had a great day learning about proportional reasoning.